Welcome back, my Algebra 2 students. We're in lesson 40, and we're going to talk about abstract fractional equations. So we have noted that the easiest way to solve fractional equations is to eliminate the denominators as the first step. As in, if we have 4 plus x, that really doesn't look like 4 plus x, does it? 4 plus x over 5 plus 7 over 3 equals 4, right? So we eliminate the denominators by finding a common denominator first. So we multiply this times this, so it gives us 3 times 4 plus x over 3 times 5, which is 15, plus 5 times 7, which is 35, 5 times 3 is 15, equals 15 times 4 over 1, so that's going to be 60 over 15, because that equals 4. Now we can multiply the whole thing by 15, and they cancel out, so we end up with 3 times 4 plus x plus 35 equals 60. So this becomes 12. This becomes 3x. So when we do our squish and swim, we end up with 3x is equal to, that'd be 47, so that'd be 13. So x would equal 13 over 3. So we learned how to find a common denominator and eliminate it. Because it is an equation, we can multiply. We can do the same thing to every term in an equation, and the equation remains constant or true. It remains balanced. So whatever you do to one side, you have to do to the other side. So if we multiply this side by 15, that cancels. And if we multiply this side by 15, right, all things by 15, it all cancels. And that's what leaves us with the numerators as whole numbers. So that is what we can do for some of these abstract fractional equations that we have coming up. So let me show you what I mean by abstract fractional equations. Let's just jump into 40.1. In the solution of abstract equations, we assume that no variable or combination of variables in any denominator equals 0. That is key. If it equals 0, then we have an undefined or indeterminate problem, and we don't want any of those. So it's a given that none of the variables in the denominator equals 0. So we have, for 40.1, a over x plus m over a equals c. These are actually kind of fun because you're not actually trying to find a number. You're not solving for x equals. You're just kind of moving the numbers around. So we need to find a common denominator. So in the case of this problem, it's xa or ax, however you want to list it. So we multiply both of these, or all of these, by ax, right? So we take both of these and we say ax times a over x plus a over x, or ax times m over a equals ax times c over 1, because it's the only whole constant we have. So we put it over 1 to make it a fraction. So what happens is, it's the same thing that happens whenever we find a common denominator with numbers. These two will cancel out. These two factors cancel out. And so we're left with a times a. So that's going to be a squared. Because this, when it cancels, this is what's left behind is a 1. It becomes a 1. Same thing here. The a's cancel out, and we're left with mx. And then here we have ax times c, that becomes axc. All right, so that is the canceled denominators. Now, next, we move all terms that contain x to the same side of the equation. I forgot to mention at the very beginning that we were solving for x. So we've got to figure out what x equals. So we want x to be on all the x's on one side. So that means we're going to say a squared equals axc minus mx. Right? Now we are going to factor out x. So we have a squared equals x times ac minus m. Can you see how that works? We undistributed the x. We factored it out. Right? Now, because these are factors, we can divide both sides by ac minus m, ac minus m, and on this side it cancels. So we end up with a squared over ac minus m equals x. And that is how you would solve for x from here. This is how you figure out what x equals in this equation. And that's why these are called abstract equations, is because you don't actually get a real number. You just get a representation of the expression. Now let's try one more. Let's do 40.2. Let me clear the page. And in this case, we're going to solve for m. It's supposed to be m, right? There we go. And here's our problem. We have x over m. I can actually write an m today. X over m plus c equals y over a. So now we're solving for m. So we have to figure out how to get rid of the m. So our common denominator is going to be ma. So we multiply everything times ma first. All right, in this case, the m's cancel. In this case, the a's cancel. So we have ax plus mac equals my. So we're going to do the same thing. We're going to take mac and subtract it from both sides and move it over here. So that leaves ax equals my minus mac. So then we factor m out. We have y minus ac. We divide both sides by y minus ac. So ax over y minus ac is equal to m. That is what m equals. All right. Kind of fun when you think about it. Kind of fun. All right. So we have one more. Let me clear the page because this is all we're doing for this lesson. So we have this last problem and then we're done. We are going to solve for p. Okay, so we have 6 over p minus ax equals m over y plus k. So m over y plus k. All right, so our common denominator is py. So py times 6 over p minus pyax equals py times m over y plus pyk. All right, the p's cancel, which leaves us 6y minus pyax equals, the y's cancel, so we have pm plus pyk. So now we are going to swim this over to this side. So we have 6y is equal to pyax plus pm plus pyk. We factor p, which leaves us yax plus m plus yk. Then we divide both sides by yax plus m plus yk. Same thing over here. Yax plus m plus yk. These cancel. So 6y over yax plus m plus yk is the value of p. All right, those are kind of fun. They're kind of fun. So I'm going to give you one now. This is from our problem set. Let me clear this page. See if you can work this one on your own. So we have c over x plus m over b equals c. And we want to solve for c. So I want you to pause the video and then come back, and actually we already have c solved for. Let's solve for b. Solve for b. All right, so pause, work it, and then come back and see what I got and what the answer is. All right, if you got xm over cx minus c equals b, then you got the right answer. So if you did not get that answer, then you need to go back and look at what I did here. First thing, we found our common denominator was bx. We multiplied that times all the terms. We canceled the x here, so that became cb. We canceled the b here, so that became xm. And bx times c is cbx. So we swam cb over to this side, which made it a negative cb. And then we factored b out of both terms. That left b times cx minus c. And then we divided both sides by cx minus c, which left, that canceled, and then that left xm over cx minus c is equal to b. So we're starting to get into the realm of logic, and pretty soon we're going to be doing some proofs. So this is just about seeing the relationship between these variables and how they interact. So if you can do this accurately, then you can also do the constants and the whole numbers accurately. This is just kind of breaking apart how we factor things, and how we can relate them to one another. So have fun with these, and I will see you in lesson 41.